Today we are going to solve one question from the interview bit, that is verify prime number. So this question basically it will give one input and integer, and we need to check whether that number is prime or not. If it is prime, then we need to return 1. If it is not a prime number, then we need to return 0. So this question basically it is a very easy question, and it is available in um, Geek4Geeks and the Lead Code platform. So let's start this one. So we'll start with basic approach, then we'll go into the in-depth approach how we can solve in minimal time. Okay, so let's get started. So before going to the actual solution, we need to understand what is prime number. So the prime number is basically the number which will have the two factors, one and itself. So let's say one example I'll give. I'll take 3. I'll take 3. So three factors are like 1 and 3. So and another example I'll take, let's say 5. So 5 will have the factors 1 and 5. 4, it will have like 1, 2 and 4. Let's say 10. So 10 will have 1, 2, 5 and 10. So if you see here, 3 and 5 are the prime number, because the factors of these two numbers are 1 and 3 and 1 and 5. But for 4 and 10, you can see there are multiple factors, so 4 and 3 and 10 are not the prime number. So these are the prime number where we need to return 1. but but if you see these are not prime number, so here we need to return as 0. Okay, so let's take the brute force approach. Let's say we'll have one number n, which is the input, and we'll take one counter int count equal to 0, where we'll count the factors of the number. So here we'll take the for loop, so it will start from 1, because 0 is not a prime number. So we'll start with 1 and till I less than equals to n. Okay, then I plus plus. Inside for loop, we need to check if n modulo I. So here it will check n with n. It will check with n modulo I. So we'll check if it is 0. If it is 0, then we'll increment the count. Okay. Now if 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 count equals to 2, then we'll return 1, else return 0. Okay, else return 0. So why we are checking this condition? Because if you see here, the prime number should be 1 and itself, and it will be the count, the factor will be the 2. Okay, factor will be 2. So that's why we are checking whether this count is 2 or not. If count is 2, then we can know that it is a prime number, so we'll return 1, otherwise we'll return 0. And now we are going to now we'll check whether so another thing is like, what is the time complexity of this approach? The time complexity of this approach will be big of n, right? Because here if you see, we are taking 1 to n loop, 1 to n iteration we are doing for each time, so it will take a big of n time complexity. And space complexity, what will be the same space complexity? Space complexity will be the constant big of 1, because we are not taking any extra space, so it is the space complexity will be 1. Now we'll go little deep depth. So we'll check why. What is this the best solution? So we'll take one example like, say, mm, okay, say 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 one in 1 second in my computer, in 1 second I am doing 10 to the power 8 iteration. Okay, in 1 second I am doing 10 to the 8 iteration. So one iteration, so one iteration will take how much time? 1 by 10 to the 8 second, right? Right. So one iteration will take 1 by 10 to the 8 second. My n is, let's say 10 to the power 9. Okay. So for 10 to the power 9 iteration, so 10 to the power 9 iteration, how much time it will take to execute? So 10 to the power 9 into 1 by 10 to the power 8. So it will have like 10 second, right? So it is this with this input, it is correct. Means 10 to the second is fine. The solution is fine. Let's say my number is 10 to the power 18. It is increased to 10 to the power 18. So now 10 to the power 18 into 1 by 10 to the power 8. So what is the value? So now the value will be 10 to the power 10 second. Okay, so approximately it is like 317 years. So do you think this solution will be work for this big number? So I don't think it is a it is a good solution, because it is taking for 10 to the 8 numbers to check the prime number. It is taking 317 years. So it is not a good solution. Okay, now we need to find the some solution where we can do this checking, prime number checking, in minimal time. So let's see how we can achieve this one. Approach 2. So in approach 2, before going to the approach 2, so just we need to know one formula, like, if I want to, so the product of A and B, the product of A and B will be the n. Okay, let's say A and B, A into B equals to n. Say I know the A value and I know the n value. So how can I get the B value? So to know the B value, we need to do n by A, correct? Now, let's say my number is n is 24. Okay, my number is 24. So, and A, let's say I know the A, I don't know B. Okay, I know A, I don't know B. So in that case, I need to do n by A, then I'll get the B. Okay. So here in the A, I'll write all the multiple of 24, like 1, 2, 3, 4, 6, 8, 12, and 24. Okay. So from here I can get the B value by dividing n by A. So Now if A is 1, then my B will be 24. If A is 2, then B will be 12. A is 3, B will be 8. A is 4, B will be 6. 6, 4, 3, 2, 1. Okay. Now observe one thing. Now observe one thing. Till here, till this, we are getting all these numbers. 1, 2, 3, 4, 24, 12, 8, 6. All the factors of 24 we are getting here, right? So we no need to go to this point. We no need to go to this point. So we if you see here, a value is less than in till this point. Here a value is less than b, right? So we can write like this. So we can write like this: a less than n by a, less than equal to n by a, right? Now we can have one formula like a into a less than equals to n, right? We can do like this: a square less than equals to n, right? Then a will be root over of n. Okay, so from this formula we can get to know we no need to go each and every elements, and no need to check for the uh, prime number. So we know we need to go to till root over of n. I mean till here we need to go in the loop. So so let's write that one. Let's write the uh, code. So I'll take int count equals to 0. Okay, then for loop I'll take for will go I equals to 1, I into I less than equals to n, I plus plus. Okay, here I into I means this one. I into I means I into I less than equals to n, right? So same thing. Okay, so now here I need to check if n modulo I equals to 0, then I'll increment the count. Okay, okay. So another thing I need to check. See here, one more thing we need to. Okay, let me write that one first. If I not equals to n divided by I, then I'll increment the count. Okay, so why I'm writing this one? Why I'm writing this point? So we need to check perfect square condition. So in the what is perfect square? Perfect square is 6. Let's say 6 into 6 is equal to 36. So this is a perfect square, right? So here we are not getting multiple two numbers, we are getting only one numbers. So we'll need to increment only one. No, we cannot take consider this as a two separate numbers. So this is a same number, so we need to consider and we need to increment to one. Okay, so that's why we have we are handling this condition. Okay, now here what we'll do, so now what we'll do, here we need to check if count equals to, then we'll return 1, otherwise we'll return 0. Okay, so this is the solution. So this is the solution. So let's dry run with with some value. So so my computer is running in 1 second doing the performing task like in 1 second 10 to the power 8 iteration. Okay, so one iteration is taking 1 by 10 to the power 8 second. Okay, now n is equal to take 10 to the power 9. Okay, so so here if you see we are using here if you see we are using like root over of n. So what is the root over of 10 to the power 9? So root over of 10 to the power 9 will be approximately 10 to the power 5, right? So the iteration will be the 10 to the power 5 equals to so 10 to the power 5 divided by 10 to the power 8. So it will be 10 to the power minus 3 seconds. So it is improved, right, from the previous solution. Now we'll check with the big number. Now n is equal to 10 to the power 18, let's say. So root over of n will be what? Approximately 10 to the power 9, right? Now, so for 10 to the power 9 iteration, it will take how much? So 10 to the power 9 divided by 10 to the power 8, to 10 second. So now if you see, it is taking only 10 second, but the previous approach it was taking 317 years. Now if you see, this is the optimal solution we have. We are not using we are not taking 317 years. Okay, so let's code it and we'll check whether it is working. Okay, so here let's say I'll take int count equals to 0. Okay, now I'll take for loop int I is equal to 1, I less than equals to I into I less than equals to a I plus plus. Okay, now if so I'm writing in Java 8, you can use any language, the logic will be same. You can use Python or JavaScript or any language or C++, anything, the concept will be same. If 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 a modulo I equals to 0, right? If modulo I equals to 0, then count will increment to 1, and here we need to check whether it is perfect square or not. Okay, so here I is not equals to n by I, a by I. Okay, then only I'll increment count plus plus. Okay, now if count equals to 2, then it is a prime number. I'll return 1. Otherwise, I'll return 0. It is not a prime number. Okay, so we'll test it first. Yes, test is successful. We'll submit it. Yeah, so it is working fine. So this code is most optimal solution for this problem. Yeah, so that's all. If you have doubt, then you can comment down. So thank you for watching this video.